In this lesson, we're going to turn our lane marking curves into meshes and start adding materials to them. First, let's give ourselves more space between the join geometry node for the curves and the group output. To turn the curves into meshes, we'll use the curve to mesh node. This is just like we did earlier with the pavers. We also need a profile curve, and for that we'll use a curve line node. We don't need to make it adjustable here, so I'll just give it a fixed size of 0.1 meters wide. To center the profile, we'll set the start point to 0.05 on the x-axis, and the end point to 0.05. Now plug that line into the profile input of the curve to mesh node. This will turn our lane markings into actual mesh geometry. Right now it's hard to see them clearly because they're sitting at the same height as the road mesh, which causes Z-fighting. That makes the two meshes overlap visually in a strange way. To fix this, we can just raise the mesh slightly using an extrude mesh node. When you extrude, make sure to untick individual so that we don't get weird, disconnected pieces. Also, we don't want these markings to be tall like walls, so set the extrusion offset to 0.02. That gives a small height above the road, which looks okay. You can also enable shade smooth for better results, but I'm actually going to turn shade smooth off to make the markings appear more solid. This avoids strange lighting effects on thin mesh. Before adding materials, I'll go back out to the main lane markings group. At the very end of the node tree, I'll add a set position node. I'll use it to raise the whole structure off the grid slightly. Let's move everything up by 0.05 instead of 0.1, which looks better. This helps us view the lines clearly, especially in the 3D viewport. Speaking of that, go to the View tab and adjust the clip start and end values to help reduce clipping when zooming in close. Now we're ready to begin adding materials to the line markings. But we don't just want a single color. We want it to change depending on the line type. Different types of lane markings can have different styles. Some roads use white lines, others use yellow. Some are dashed, some are solid, and sometimes there's a double line. We want this to be fully procedural and change automatically based on the number of lanes or the duplicate index. Let's go back into the lane markings group. We'll build the system so that certain lines like the center are yellow, and others can be different types later. To do this, we'll start by creating a material in the shader editor. Add a new material and call it line markings. We'll revisit the road and paver materials in another lesson, so we'll focus only on the lines for now. I'll increase the roughness of the material so it's less shiny. Then I'll add an attribute node in the shader and name it line call. This will let us send a custom color from geometry nodes to the material. Hook that attribute's color output into the base color of the material. To use this material on the mesh, add a set material node in geometry nodes and assign the line markings material to it. At the moment, all the markings turn black because this line call attribute doesn't exist yet. So we need to add it. Right after converting the curves to mesh, use a store named attribute node. Paste in a line call from the shader to make sure the name matches. Set the data type to color. This will let us change line colors inside the geometry node setup. But instead of one fixed color, we want different colors for different lines. So we'll add a switch node and change the output type from geometry to color. For the true value, I'll use a nice yellow color. For false, I'll use white. Now we can toggle between yellow and white based on some logic. Next, we need to decide when to apply yellow or white. We'll use another named attribute, but this time a Boolean value. Let's say true means the line is the center line. Inside our cyclical lane markings, find the curve you want to mark as the center. To fix this, we use a math node set to a ceiling. This will round 1.5 up to 2, so it always picks a center line correctly. For example, if the number of lines is 3, then half is 1.5. The ceiling of 1.5 is 2, which becomes our center line. If you want more control, you could add a switch in the UI to flip which side gets the center line. I won't do that here, but you could add it later. Let's switch our number of lanes back to 4 for now. Next, we'll apply the same method to the straight lines. It's usually the one halfway across all the lanes. We'll set up a Boolean attribute named center. Add a store named attribute node and make the data type Boolean. Then create a compare node to check whether the duplicate index equals half of the number of lines. Connect this logic to the Boolean input. Use that same center attribute in the color switch node to pick between yellow and white. Now the center line is colored yellow automatically. This works great for even numbers of lanes. But what about odd numbers, like 3 lanes? In that case, the middle index is 1.5, which doesn't make sense. The logic for straight lines is similar, but not exactly the same. Because we have a different number of duplicates here, the math changes a little. Move the duplicate elements node to give yourself room. Add a store named attribute node and name the attribute center again. Set the type to Boolean. Let's test if it works correctly. Multiply the number of lines by 0.5. Use a math node to set this up. Add a ceiling node to round up the result. Compare it with the duplicate index to see if it's the center. But this still doesn't give the correct line in our setup. So we'll use a math multiply add node instead. Keep the multiply as 0.5, but set the add value to -1. This means we subtract 1 from the result, which shifts the center to the correct line. Now it works just like the cyclical version. No matter how many lines you add, The center line is always yellow. In the next lesson, we'll expand this setup further by adding dashed line types to the separators between lanes.